Now recall that in the previous lecture, we learned how to solve the characteristic equation by using one of the three methods: direct factoring, factor by grouping, or using quadratic-like equations. Today, we will look at examples where synthetic division will be needed. So let's look at an example here. Example 1, we want to solve the following ODE: y triple prime minus 3 y double prime plus 4y equals to 20 cosine of 2x. So as usual, this is the non-homogeneous equation. To solve this equation, we first solve the corresponding homogeneous equation. Y triple prime minus 3 y double prime plus 4y equals 0. And we have the characteristic equation. Third derivative gives us a cubed minus 3. Second derivative gives us a squared, and there's no first derivative. And lastly, we have 4y gives us just 4 equals 0. So the goal here is to determine the values of r. Find the roots r here. So how do we do that? Now, direct factoring will not work because we don't have any common factor from the three terms, and we cannot do factor by grouping either because we only have three terms, and it's not quadratic-like. For quadratic-like equation, we should have only even powers of r. Here we have r cubed. So we need to use a different method. And the idea here is we try to factor. So to use the other method, we will first use trial and error to find one value of the root. Now in college algebra, you may have learned a more sufficient way to define the to find the value of r, but here we won't go into the details. So you can just try whether r equal to plus or minus 1, plus or minus 2, plus or minus 3 to see which one is a root. So try this: plus or minus 1, minus 2, etc. You don't need to check these in that order. Now for the purpose of this example, it turns out that we can use r equal to 2, and this is a root. R equal to 2 is a root because if you plug in, you will have 2 cubed minus 3 2 squared plus 4, which is 8, minus 12 plus 4, which is 0. So it is a root. And therefore, If we rewrite the equation here, r cubed minus 3r squared plus 4 equals 0, it should be factored as r minus 2 times something here. And we need to determine this. So you may use long division to do this, or a synthetic division. So over here, I will discuss synthetic division. So first of all, let's rewrite the equation, the polynomials here, by filling all the mixing powers of r. So we should write r cubed minus 3r squared, and then r is mixing, so I will use 0, r plus 4. Now for synthetic division, we'll set up as follows. We only use the coefficients in front of the powers of r. That's going to be this coefficient 1, -3, 0, and +4. And we set up the division as follows. What we have found above is root 2. Okay? And then we use the coefficient, rewrite here as 1, -3, 0, and 4. This is the coefficients to begin with. Now, whatever the number, the first number here, we rewrite it down here. And then we take this value, multiply by the root, which is 2, and rewrite it down here. And add them up. -3 plus 2 becomes -1. Now continue. We use this number, -1 here, multiply by the root 2, we get -2, and then add vertically. -2 plus 0 plus -2 give us -2. Continue. -2 here times 2, we get -4, write it here, and then add vertically, we get 0. Now, in general synthetic division, this is the remainder. But because 2 is a root, the remainder must always be 0. And these three coefficients give us the quotient. Now we begin with, back here, we begin with r cubed, and we divide by r minus 2. So the quotient begins with r squared, and the quotient is 1 degree less. It's going to be r squared. And using these coefficients, give us the quotient of 1 times r squared minus 1 times r minus 2. That is the quotient. And so we factor the characteristic equation as, remember that we already have a factor r minus 2 in front, and now after using synthetic division we have the quotient, r squared minus r minus 2. So the quotient is the second factor. And because we have a quadratic equation here, we can just factor or use quadratic formula to solve. Now in this case, we can actually factor to get r minus 2 and then r plus 1 equals 0. And solving for r, we have three values. R equal to 2, that's the first. The second one is also 2. And lastly, we have negative 1. So we get y1 as usual, e to the 2x. y2, we have repeated root, so we need to multiply by x, e to the 2x. And then y3, e to the negative x. That's the first step to solve for the non-homogeneous equation. Now, find capital Yx. This is exactly the same as before. We need to look at g of x. And in this problem, g of x is 20 cosine of 2x. So we have our guess. This is the initial guess. A cosine of 2x plus b sine of 2x. And we need to know whether we need to modify or not. But by looking at the formula, we have a times cosine of 2x, and cosine of 2x is not y1, y2, or y3, and the same for sine of 2x. So we don't modify. We need to take derivatives. The original equation has third derivative. We need to take the derivative 3 times y prime, y double prime, and y triple prime. It's a little bit lengthier than usual because we have more derivatives. So I'm not gonna show you the details here. So instead, after we take derivative, we plug into the non-homogeneous equation, collect like terms, and solve for a and b. Solve for a, b. So I will just write down what a is. It turns out that a is 1 and b in negative a half. So capital Y x is cosine of 2x minus a half sine of 2x. And then we have the final answer to the problem, which is y equal to c1y1, which is e to the 2x, plus c2y2, which is x e to the 2x, plus c3 e to the negative x, plus capital Y, which is cosine 2x minus a half sine of 2x. And this is the answer, the general solution to the given non-homogeneous equation. Now let us look at another example. Solve the ODE. y triple prime minus 3 y double prime plus 3y prime minus y equals e to the x. So as before, we begin by solving the homogeneous equation. We have the characteristic equation r cubed minus 3r squared plus 3r minus 1 equals 0. As before, direct factoring will not work, and factor by grouping does not work either, because if you group the first two and the last two after factoring out r squared in the first group, you don't have common factor, and it's not quadratic-like equation either. So let's use trial and error to find a root. You check the r equal to 1, 2, minus 1, minus 2, etc. to see which one works. And it turns out r equal to 1 works because, right, 1 cubed minus 3, 1 squared plus 3 times 1 minus 1 that is equal to 0. So now we're gonna use synthetic division. The equation has all the powers of r, so we don't need to fill in any missing powers. Set up the synthetic division. The value we have found is 1, and the coefficient we have 1, negative 3, plus 3, and negative 1. 1, negative 3, plus 3, negative 1. And now use synthetic division. This bring down, and then we take this, multiply by 1. We get positive 1, and add up to get negative 2. Negative 2 times 1, we have negative 2 here. Add up, we have 1. 1 times 1, we get positive 1. Add up, 0. As before, this is a remainder, and because r equal to 1 is a root, it's supposed to be 0, no remainder. And we get the quotient. Quotient begins with r squared. The 1 times r squared minus 2r plus 1. So we have factored. As always, r minus 1. This is the root we found at the beginning. And then we have the quotient, r squared minus 2r plus 1, 0. We factor again. It turns out we have r minus 1 and another r minus 1. So we have 3 values of r, but all of them are 1. Repeated 3 times. And I should write 1, 2, 3. And so y1 is e to the x. What about y2? Repeated root. We need to multiply by x, x e to the x. What about y3? Repeated again. We need to multiply again by x to get x squared, e to the x. These are the three solutions to the homogeneous equation. Now we need to guess and find capital Yx. We'll recall that g of x is e to the x. Over here. So our initial guess for capital Y will be a times e to the x. This is a constant multiple of e to the x. But then this is the same as y1. So we need to modify by multiplying by x. So a x e to the x. So now capital Y is a constant times x e to the x. But if you look at y2, and this is same as y2. Modify again. By multiplying by x, we get a times x squared e to the x. But it turns out x squared e to the x is the same as y3. And now you know what to do. We need to modify one more time by multiplying by x. And this time we may use it to take the derivative and plug in the non-homogeneous equation. It's a little bit lengthy here, but the derivative using the product rule will have 3x squared e to the x plus x cubed e to the x. Second derivative, a product rule, we have 6x e to the x plus 3x squared e to the x. And then product rule for the second term, we have 3x squared e to the x plus x cubed e to the x. Collect like terms. We have 6x e to the x plus 6x squared e to the x plus x cubed e to the x. Derivative one more time. Y cubed a. This time we have three terms. We need to use the product rule 3 times. 6 e to the x plus 6x e to the x. So you need to be very careful. Plus 12x e to the x plus 6x squared e to the x plus 3x squared e to the x plus x cubed e to the x. Collect like terms, we have a 6 e to the x plus 18x e to the x plus 9x squared e to the x plus x cubed e to the x. Now we need to plug in the equation. Plug into a non-homogeneous equation, which says that y triple prime minus 3 y double prime plus 3y prime minus 3y minus y equals e to the x. So keep in mind, I need to multiply the second derivative by minus 3, the first derivative by 3, and then subtract capital Y. Now do all the algebra. It's a little bit tedious to do all the algebra, but it turns out everything would cancel out except that we have 6ax left. 6a or e to the x left, and on the right hand side we have e to the x, so we can solve a to the 1 over 6. Now I would recommend that you try to do some computation. So for example, let's look at the highest power of x here. We have x cubed e to the x, so we have ax cubed e to the x, and then we subtract 3ax cubed e to the x and plus 3ax cubed e to the x, and subtract the last one, ax cubed e to the x. Everything would cancel out. So we cancel that factor, that term. And then we do for x squared e to the x, and then x e to the x. But anyway, we have a equal to 1 over 6, so capital Yx is 1 over 6 x cubed e to the x. And we get the final answer, the general solution. Y equal to c1 y1 e to the x plus c2 x e to the x plus c3 x squared e to the x, and lastly is capital Y 16 x cubed e to the x. Now I want to show you another example with order 4. We want to solve the ODE y to the 4th derivative minus 8 y prime equals to 8x minus 1, our non-homogeneous equation. The corresponding homogeneous equation is the fourth derivative of y minus 8y prime equals 0. So the characteristic equation, r to the 4th minus 8r equals 0. So as I mentioned in the previous lecture, whenever we solve for characteristic equation, we should try to see if direct factoring works. And in this case, it does work because we have the common factor r. So factor it out first. R times r cubed minus 8 equals 0. So when we solve, we will have r equal to 0, and then r cubed minus 8 equals 0. However, the second equation would have 3 roots. If you take cube root of 8, you only have 2. That's not enough. It turns out we have 2 more complex roots. In order to do that, in order to determine the complex root, we need to use factoring. We need to use long division or synthetic division here. So let me write first r equal to 0, that's the first one. And then we have r cubed minus 8 equals 0. This, we know that has a root r equal to 2. But we need to factor r minus 2 times something here. We need to determine what it is by synthetic division. So let's rewrite here. R cubed minus 8. In order to use synthetic division, we need to fill in all the mixing powers. R cubed plus 0 R squared plus 0 R minus 8. Now set up synthetic division. We have found the value of 2 is a root, and the coefficients 1, 0, 0, negative 8. As before, we print this down. 1 times 2, we get 2, print it down. 0 plus 2 is 2. 2 times 2 is 4. Here, 0 plus 4 is 4. 4 times 2 is 8. And negative 8 plus 8 is 0. And let's see good. The remainder must be 0 because R equal to 2 is a root. And we have the quotient, which is R squared plus 2R plus 4. So we factor R minus 2, and then the quotient is R squared plus 2R plus 4 equals 0. Now solving, we have R equal to 2, and then R squared plus 2R plus 4 equals 0. It turns out that we wouldn't be able to factor this second equation. Instead, we need to use quadratic formula. For R squared plus 2R plus 4 equals 0. So I'm not gonna go into details. Instead, I would just write out the answer for you. It's minus 1 plus or minus square root of 3 times I. So we get the root. Let me rewrite all the root. We begin with order 4, so there should be 4 root. And recall, at the very beginning, we have R1 here is 0. And then the second, we have R2 here. And lastly, we have R3 and 4. Let's rewrite this. 1 is 0, 2 is 2, and lastly, we have a pair complex root. So 3, 4 here. Because of this, we get y1 is e to the 0x, which is just 1. y2, e to the 2x. Because of the complex root, y3 and y4 has trigonometric in it. And recall, this is alpha plus or minus beta I. Alpha is negative 1. Alpha gives us exponential e to the minus x. And then beta gives us sine cosine. Cosine square root of 3 times x. And then y4 e to negative x. Sine of square root of 3x. Now, we need to find capital Yx. We have our initial guess. Let's go back. This is g of x. It's a polynomial which contains all the powers of x. So our initial guess, capital Y, would be ax plus b. A times x plus b, which is b times 1. And we need to check whether we have to modify or not. It turns out this is the same as y1. And we need to modify by multiplying by x. So it should be b times x. And as before, by the domino effect, we need to multiply this by x as well. We get x squared. Now we find the derivative. 2ax plus b. Second derivative, 2a. Third derivative is 0. And fourth derivative also 0. Now plug into the non-homogeneous equation, which let me recall here, y to the fourth derivative minus 8 y prime equals to 8x minus 1. The fourth derivative is 0, so we only need to use y prime, which is 2ax plus b. So we get 0 minus 8 times 2ax plus b equals to 8x minus 1. Distribute, we get minus 16ax minus 8b equals to 8x minus 1. Equating the coefficients, we get minus 16a equal to 8. From here we solve for a, which is minus a half. And then minus 8b equal to minus 1. So we get b is positive 1/8. So we have found capital Yx is minus a half ax squared. So minus a half x squared plus b8 plus bx. So 1/8 times x. And our general solution, need to write on the next page that y equal to c1y1, which is 1, plus c2y2 e to the x, plus c3 e to the negative x, cosine square root of 3 times x, plus c4 e to the negative x, sine of square root of 3 times x, plus capital Y, which is minus 1/2 x squared plus 1/8 x. And this is the end of the lecture.